Hello and welcome back. It's puzzle time with Sudoku and today we're going to be playing Positive Negativity 3. I know it's not quite spelt out there on the thumbnail, but I am trying to sort of fit it in on the screen. Now, we actually featured one of these before from the Bard, and I'll be honest, I think the feedback from you guys was a little bit mixed, but I think it's predominantly because some of you struggle to wrap your mind around the rules. So I will be carefully walking you through it and kind of my interpretation of it. And I'm hoping after that, this will be a highly enjoyable puzzle for everyone. Anyway, let's take a look at today's puzzle and rule set with Positive Negativity 3 by the Bard and the following set of rules. So normal Sudoku rules apply, very familiar for everyone. Place the digits 1 to 9 once each in every row, every column, and every 3 by 3 box. So nothing unusual here. From here on, there's this whole, actually no, Yin Yang, and then we'll talk about values. Second rule is Yin Yang. We need to shade some cells so that all the shaded and unshaded cells form two orthogonally connected areas such that no 2 by 2 area is entirely shaded or unshaded, and all the digits values in the shaded area are negative values. So a lot of words there. Let me explain. Essentially, I'm going to pick blue and red because you'll kind of get the concept why in a second. But we need to basically be able to somehow shade the entire grid in two colors, and very specifically two colors. The colors, as in the blue, for example, in this particular case, needs to be orthogonally connected to itself. So orthogonal, just a quick reminder, is essentially kind of north, south, east, west. Diagonals don't count. Second thing is, I can never form a 2 by 2 area of the same color. So the second I made that red, I have broken the puzzle. I can, however, make that blue. That's absolutely fine. Now, one of these colors, the digits that are on there are negative, and one of these colors, the digits that are on there are positive. Hence the positive negativity kind of title. Right, anything else to mention about the rules? Obviously, this has to cover the entire grid. So, for example, if I isolate, I connect all of these with red, I have isolated this blue, and that's not possible. There has to be two contiguous areas, one red, one blue, uninterrupted. So this would have to be blue, for example, so that it can escape and connect to this cell. Can't color this, so that would have to be red. Can't make this red, would have to be blue. I've already broken it with this 2 by 2. So you can see it's actually a powerful constraint. Right. Second is now the concept of values and that whole positive and negative item. So killer cages, the values in the cages add up to the total in the corner. So it means that the positive value in blue, the negative value in red, so essentially blue minus red, is equal to 2. Blue minus red is equal to 5. Blue minus red is equal to negative 6. That's the idea here. So in this particular case with negative 8, for example, I could place 1, as in plus 1, minus 9. That would give me minus 8. Second thing, the Kropki dots. So values separated by a white dot must be consecutive. So, for example, if I place 4 and 5 in here, actually probably the other way around would work better. These two cells are clearly consecutive. But because we're focused on the values, they can't be of different color because that would be plus 4, that would be negative 5. There's a difference of 9, not a difference of 1. So the colors absolutely have to be the same on the white Kropki dots. So that's all the rules we have for today. Plenty of rules, actually. As always, for you to play along, link will be in the description down below for you to do so. And with that said, I'm going to restart the clock and see how I get on. Now, I feel like given we've had a kind of an influx of new subscribers, it's probably worthwhile just quickly revisiting some kind of known, I don't want to call them best practices, known tips about yin and yang cells. First off is you can never have a checkerboard pattern. If you think around the implications of that checkerboard pattern, and kind of, you have to excuse the fact that I'm doing this in a 9 by 9 grid. the challenge that you have is if you color the rest of this in that checkerboard pattern, is how can you connect blue and red without isolating one or the other? The second I make this blue, red is no longer connected. The second I make these red, the blue is no longer connected. There is no way for you to connect the two if there is a checkerboard pattern anywhere in the grid. Right. Second kind of tip is around the borders. So imagine that, the thing is you have to have only one, as in one set of blue, one set of red. You can never have an interrupted set such as this. And I'm hoping this is a fairly obvious challenge. How can I connect blue without isolating red? And the same will be true, of course, how can I connect red, pardon me, without isolating the blues? So they have to be two contiguous strips, can't do any more than that. And obviously it doesn't have to be two, it could be just one color all the way around. I don't think there's a rule requiring you to actually touch the edge with the area, but I suspect as we actually crack on with the solve, you're going to find that this is necessary. Right, 2 minutes. I'm going to actually restart the clock now and just crack on. White dots, remember, have to be the same color. -3 tells me that these two are red. This is 1 and 2. Tens, I can never get to, kind of the way to think about this is minus, even if I make 1 is -9, it's not going to get me to -10. So tens, or anything that is a 2-digit in general, have to be the same color. So because it's negative, this has to be red. Because it's positive, this has to be blue. Positive, blue, negative, red. You can already see the problem in here. If these two white Kropki dots are red, I will make a 2x2 area and then I've broken the puzzle. So these two cells absolutely have to be positive. And remember, they have to be, the white Kropki dots have to be the same color. Same color, same color. Right, this blue has to escape. It basically needs to continue, and actually that 1, 9 that we were using in the beginning actually fits here. That's our first set of digits. Because essentially, if this blue, if I put red anywhere in here, I've isolated this blue. So this blue has to essentially escape to connect to the rest, but I have -8, so one of them has to be red, and therefore my 1 and 9 is my break-in. Blue still has to escape. Blue continues to escape, because this is a white Kropki dot, so it's continuous. This is -6, so this has to be red. Otherwise, it's not going to work. These two cells have to be the same color because this is a double-digit killer cage. And it's 12, and it's positive. This has to be blue. Now, I don't have to continue the blue, although I think I will, because of that 23. But essentially, there is a way for that blue to now escape from this section. I don't actually have to continue. Right, red here because it's -10. And remember what I said earlier about the edges. These have to be a single contiguous strip of red now. 10, it's positive, has to be blue. That could be anything. That has to be red because it's -10. Right, 23. Let me just think about this. So I'm taking a moment to think about this. I'm just trying to understand how far the blue goes. And I'm thinking that it can go as far as this, actually all the way around. And then these two negatives to make this 0. Actually, they can't be two negatives. It would have to be, because it would create a 2x2. So it'd have to 2 positives and then 1 negative. But I mean, all of that works. What I think, because of the 23 in 4 cells, is that I think I can be fairly confident. We know, for example, that these two are not red. Otherwise, we'll create a 2x2 area. So at an absolute minimum, this cell has to be blue. And then the question is whether these are blue or red. If they are red, that would make this red. And then I have another 2 by 2 area. So that doesn't work. So these have to be blue. Right, to get to 23 now. Yeah, it's not forced. That's the challenge. I can obviously do 7, 8, 9 with a -1 and make these two cells red and then positive, but this is not forced. This is red, white Kropki dot. This is red, white Kropki dot. This can't be a 2 by 2 area. This is blue, but again, white Kropki dot continues. This is red. We're getting a ton of colors, but not necessarily progressing the puzzle, if that makes sense. You can see that some of these have to be mixed. You're not going to get two cells that add up to 1. You're not going to get two cells that add up to 2 or -1. So all of these cells are a mixture of blue and red, one of each in each of these cage cells. And essentially, we're looking for two digits to have a difference of 1, difference of 2, difference of 1. 17 cage, this is 8, 9. This is 7, 8, 9. This is not 1, 2, as in not 1, 9, not 2, 8. So it's essentially 3, 4, 6, 7. Sudoku says 9s are definitely up here. Difference of 6 is actually quite difficult now that I use 1 and 9. If I put 2 and 8, so maximize these because 1 and 9 are not available, yeah, that is a difference of 6. So that was forced. That is a 3 now. Right, 1, 2, and 3. So 3, 9 not available, 4, 8 not available. This has to be 5, 7. 8s, 9s have to be in here. Sorry, I need a moment. I feel like there has to be a 5 in here. Because if you think about the remaining digits, I'm going to have essentially like, let's say 3, 7. And then I'll be left with 4, 5, 6. But 4, 6 clearly did not connect. And the same is true. If I go with 4, 6, 3, and 7 do not connect. In fact, it's kind of forcing this. This has to have a 5. And therefore it's connected with 4, 5, 6. Therefore this cannot be 4, 6. This is 3, 7. And therefore this is 4, 6. And then that gives me 7, 8, 9 at the top. That is 24. This has to be a -1. That's red. That's also red. And obviously I need to connect them. That's red again. Can't create a 2 by 2 area. That's blue. And we're off and racing again. I mean, I say that and then immediately pause. Again, 1, 2 here. This is, 4, 6, 3, 7. Not sure. 10. 7, 8, and 9 are gone. This has to be 4, 6. That 1 gave me 2 and 1. 3, 7 gives me 5 and 7. These two cells are 4, 6. Now, interestingly, probably for the 5, if this is 4, this would be 1, and both would be positive. If this is 6, this would still be 1, except this would be positive, this would be negative. So this is definitely positive. This is definitely always 1, but I don't know the color of this one or that one. These now are, what are the remaining cells? 2, 3, and 5. You can tell what that forces it to because we need to have a difference of, well, no difference. So one of these is, hang on, let me just think about this. I was about to say this is 5 and this is a -2, 3, but I'm not sure this is forced. I could have the, oh, of course it is. 1 connects to 2, therefore this is the 5, this is the 3. This has to be red. Yeah, we're good. Don't know why I missed that Kropki dot entirely. We're back to 3, 4, 6, 7 in here. Half tempted to pencil mark these, but at the same time, not really. 6 cage, very troublesome because, of course, it could be 1, 2, 3, but with positive and negative, I can't force anything. Where do I go from here? I mean, difference of 5 is a little bit large, but at the same time, it doesn't have to be a difference. I could do something like 1 and 4, both negative, and that gets me to -5. So that's not useful at all. These cannot be red. It has to be blue. The white Kropki dot forces another blue. This could be either. I'm suddenly a little bit stuck, actually. Where am I going with this? Oh, here is something. Here is something very unusual. Look at this white Kropki dot. So the rule about white Kropki dots is you have to have an odd digit and an even digit. You can't have two odd digits, 1 and 3, that are consecutive. You can't have two even digits that are consecutive. Now notice I've got 3, 5, and 7, so either this is 1, 2, or 8, 9. And you can see that the 1 is almost forced in here. The 1 is in one of these three cells, but again, I've covered how this could be 1, this could be 4, and they could both be red, and that's fine. This is obviously blue, can't create a 2 by 2 area. One of these at least is blue. Obviously, it can't be both. One of them is so that this blue can escape. Both would create a 2 by 2 area. Right. Difference of 2. 1 and 2 are gone. 3, 5 works. 4, 6 doesn't, it breaks this cell. 5, 7 works. Again, 6, 8 doesn't. And then 7, 9 does. So we have essentially two odd digits in here with a difference of 2. Not enough. It's like somehow this suddenly became a parity puzzle, which is quite interesting. Yeah, not a very useful pencil mark. Where am I going with this? Right, not keen. Absolutely not keen, but I am going to do this. 3, 4, 6, 7. Because we've got these white Kropki dots that may be helpful. So consecutive with 3, 4, 6, 7 is basically everything. No, not very useful. These two cells are consecutive. I feel like there's a very similar trick at play in here. Again, you could see that with 1 and 2 gone, how about actually, I can use 8 and 9. Nothing stops that. I feel like I'm missing some obvious next step. Such as this is blue. 2 by 2. Consecutive, white Kropki dot has to be blue. Right, so either this is 1, 2, 3, and this is not 1, this would be 1 and 2, this would be 3. And all of that would be blue. That's totally fine. What is the other possibility in here? Because of these cells being positive, obviously I could go for a highly, this can't be red, sleuth, wake up. If it's red, I've isolated the 5. That's blue. This is forced. That's not what I meant to do. That's 5, that's 3. This is 1, 2. This cannot be 3, 7. This is 4, 6. This is now 3, 5, 7. Obviously, even goes to odd, goes back to even, and it can't be 2. So this is 4, 6, 8. If I can type. 1, 2, 3, 4, 6. Difference of 1 now is actually not that easy. I feel like this can only be now 7, 8, 9 with a definite 8. Essentially, with the remaining digits, I have a 5, but it's not available next to 4 or 6. And then the 3 remaining digits above 6 is 7, 8, 9. Now, one of these cells is 5. It can only be this cell because of Sudoku. I've got a 7, 8, 9 triple. I obviously had known that because the 8 can only be in here to make sure that one of them is odd, one of them is even. 7, 8, 9. Obviously, this could still be the low digit, so not necessarily helpful. This is another 7, 8, 9. Can't be 8. The 8 needs to be in here. What was... Sorry, I'm gonna... Oh, one of them is negative, one of them is positive, and I don't know which one. Not sure. I have a 789 triple in here. I'm going to use this for a second because the rest of these are 2, 4, 5, and 6. Now, to be consecutive here, I know that, well, I don't say, I know that there is no 5. 2 is clearly not consecutive with 4, 5, or 6. 2 is off the table. 5 cannot be inside the 10 cage, so that's out. So this has to be 4, 6 as well. That's, to get to 10. And to be consecutive with 4 and 6, this has to be the 5. And there's a definite 2 in here now. Definite 2 in here. Interesting. That 4, 6 pair gave me a 5 in here. An unknown digit there. There's a definite 2. All right. We did say that these are odds. Not helpful. White Kropki dot. 4, 5, and 6 are gone. This could be 789, can't it? Yes, it can still. So it's either 789 or it's 1, 2, 3. If it's 1, 2, 3, the 2 would be in here. This would be the 1, and then that would be the 3. If it's 789, I end up with a triple still. Interesting. Very interesting. And sorry, I'm gonna bear with me because I think it's actually solvable. I'm gonna show you with what I think won't work. I don't think 789 works. Creates a triple. This would have to be 2. And then, right. So 789 triple, 4, 6 pair. And then in here is 1, 2, 3. No, and 5. Now, difference of 1 can't be 5. It's too far away from the rest. That would force a second 2 to be a difference between the 1 and 3. But the 2 is already placed. So yes, this is forced with 1, 2, 3. There has to be a 2. That forces this to be 1. This becomes 2, 3. This becomes 2. This is not 1, 2, 3. Remember, I needed a 5 in here. And the 5 can't be there because 4 and 6 are not available. So that's the 5. Yes. This has to be a difference of 2 from the 5. So it's either 3 or 7. And then this is 7, 8, 9. And once again, the 8 has to be in here. That's not the 8. Therefore, this is the 8. Still don't know which one's positive, which one's negative, depending on the value of this cell. Same here. I don't know which one's positive or negative because this could be 3 or 7. 9, you can see, is not there. 9 is, in fact, in one of these 2 cells. It actually can't be the cell because that would create 9, 8, and then break this cage. So that's 9, that's 8. Because it's -1, that's the red cell, that's the blue cell. That removes 9 from here, and therefore this is not 8, 9, this is 1, 2. That's not my 2. That is my 2. And then these cells now, well, this can't be 1, are 4, 6, and 8. You can see the 8 has to be in here. And this is a second 4, 6. And this would have to be 3, 7, because that's the remaining item in the box. And yes, they can easily be consecutive. The 8, to get to -5, fairly sure I'm not going to get to -13 in here. So that is the positive digit. This is the negative digit. This has to be a 3. This has to be -8. 3 gives me 7. And therefore, this is my positive digit. This is my -1. These two have to be the same color. And actually, both seem to work. But I do know that with this 7, this is 3, this is 4, this is 6. And it's not enough to break this 4, 6. Interesting. These 2 cells, well, I have a second 4, 6, which has to be in here. And then another, no. What do I have remaining? I have 5, 7. Right, so the 5, 7 is in here because they can't be consecutive. then I have 5 or 7 with 4 or 6. Not useful. 5, 7 in here to be consecutive. That's an even digit of 4, 6, 8. Can't be 8 because these cells to be consecutive, you know, one of them is 9, one of them is 8, or one of them is 7, one of them is 8. There is no 8, so this is 4 or 6. Now back to this being consecutive. This is 3, 5, 7. This is not a 4, 6 cage. Sorry, 10 cage. It's not a 3, 7, 1. So this is 1, 9 or 2, 8, and both at the moment still work. You could see that the smaller digit, the 1, 2, is in here. And the reason I say that is if I go with 8 and 9, and I put the 8, 9 here, the 1, 2 there, how am I going to make this white Kropki dot work, given this is 8? That would be 9, that would have to be 8, that would break the puzzle. So this is 1, 2, this is 8, 9. 1, 2 in here is another 1, 2 because it can't get to 3. It's not escaping. So I end up with a 1, 2 pair. I have an 8, 9 pair, so that's not the 8, 9. The second 8, 9 that I'm after is somewhere in here. And it's not this cell because that would have to be, well, I mean, it can't be 7, but it actually can be another 8, 9. Never mind. Not 1. 1 is in one of these two cells. Then I have 2 of 7, 8, and 9. So one of them is in here, where it's not 7. And to be consecutive, I mean, I'll put in 7, 8, 9, but it's not 8. So one of these two cells has to be 8 to be consecutive. That's the only one that can be 8. This is not 8. Remember I said these two cells have to be connected by something that is 8. That's the one that can only be 8. That's 9. That gives me 8 in here. That's 2. That's 1. That's not 1. That's 1. That's 3. That's 2. Lovely. Suddenly like collapsing like a house of cards, so to speak. This is 7, 9. This is another 7, 9 to complete the grid. Still don't know any of the colors, by the way. 7, 9 pair means that's not 7. This is 3 or 5. I should know what it is. 3, yeah. That's 5, which is the less helpful one because both 4 and 6 are still valid. So I have another 7, 9. Here, 3, 7, 9. There's a definite 3 in there. If this is 3, that would be 4. If this is 7, that would be 6. 4, 6 pair. That is all possible. The only thing that's not possible is this being a 9. So if this goes 5, 6, 7, that would be 4, 3. This goes 5, 4, 5, that would be 6, 7. Yeah, I don't know. We said something about this being there's a 4, 6 with a 5 or 7. Not helpful right now. This 9 gave me a 7, which tells me that the positive value is the 8. That's the bigger digit. That is red. Feels very likely that this is blue to connect it, but again, doesn't have to be. Does it not? Yes, it does, because otherwise it will create a checkerboard pattern. So that is definitely blue. That can't be 2 by 2. This is red. These two are the same color, and they can still be either still. Not helpful. Of course, the 1 in here, to get to 5, this has to be the 4, this has to be the 6. So now we know that there's a definite 4 in here to be consecutive with 5 or 7. This has to be 4, 5. That 5 gave me 4 and 5. This is 7, which can only be connected to 6. 7 and 6 gives me 4 and 3 in here. And then a 7, 9 pair, which is unresolved still. This can be red. This can be red. This can't be blue, so this is definitely red. Let's do that. If this is red, it's fine. If this is blue, it's fine. Obviously, it depends on how whether this is blue or not to connect. But 8 and 4 tells me that this is either 1, 9 or 3, 7. The 1 and 3 are in here. The 7 or 9 are in there. Because obviously 2, 8 and 4, 6 are not available. And how is that helping me? These two cells are known. 6, 9. 6, 9. No 3. I can still reach it from 4 to 5. 5, sleuth, pay attention. 7, not 4, 7 forces this to be 6, 4, 9. This has to be the 8 now. That's not 8. In fact, that 7 a while ago gave me 9 and 7. Those 4s gave me 6 and 4. I feel like I should be able to do more. That 7 gave me 9 and 7. And that 4, 6 is also resolved with 6 and 4. This is also resolved with 9 and 7. The 1, 2 are not. This 4, 6 seemingly are not. This 7 gave me 9 and 1 and 2 and 1. This is 4, 6, 8. It's not a 6. This is 4 or 8. I feel like I should be able to do better than that, but actually that 8 gave me 6, 4, 6, 8. This is a known digit. It is 4, 2. The interesting thing is I can actually finish the puzzle without coloring it, which really doesn't feel right to me. This is red. I am going to finish it. I'm going to actually attempt to color first at the end. 3 and then 5 for the solution. Fantastic puzzle. Once again, the Bard. I'm really always impressed by what constructors can do, because like I don't even understand how people can create a puzzle like that where you're constantly having to think about colors, numbers, values, sums. And I'm just always so impressed with how constructors can create all of this. Right, let's think about this. I really do want to color it. So we know to connect this blue to this blue. So what am I saying? One of these is green, one of these is purple. And I know that they're different colors because the red can't be isolated by having both of these as blue. And if they're both red, I will isolate this blue at the bottom. So they are different colors. Now, how does that help me? Now, this green, if this is green, I feel like this is purple, but I'm just trying to explain why. If this is the same color, I think, obviously because I'm kind of in my mind, I'm thinking both of these being red, I will isolate this blue. Hang on, this blue. But if it's blue, I don't think it's a problem actually, because I can make this red. And then red is still connected. So I actually don't know the color of this one. I know that these can't both be blue. And they both can't be red. So both blue creates 2 by 2 areas. Both reds isolates this blue potentially. No, it doesn't necessarily. If this is blue and this is red, we're actually okay. I think there may be multiple answers here, and there's no way of forcing it. Huh. And the problem is, now that I've picked purple and green, is I actually can't color the rest. This is fine as purple, this is fine as green, depending on what they are. The only thing I know is, as I said, these can't both be blue, but nothing wrong with them being both red. if they're both purple, and the thing is, it's two cells, they could be a mix. So I don't see a problem with that either. Yeah, I'm not sure there's a unique coloring solution. Right, regardless, I hope you guys enjoyed the puzzle and the video, and I'll see you back soon. Bye-bye for now.